In this video, we're going to take our asynchronous fetch programming logic into our React application. So last time we learned how to talk to the Open Trivia database here, and in regular JavaScript, we learned how to fetch using promises and async and await to grab data from an endpoint of that API and then load it on the page. So we ended up with something really simple like this. And what we want to do in this video is take that logic and learn how to do that inside of our React application so that when we go to the quiz page here, these trivia items are loaded dynamically from the Trivia API server instead of loaded locally from our JSON file. And this will be a really important step because this is how we are going to eventually talk to our own custom backend when we replace the Trivia API with our own setup. Before we get started, though, we have to revisit the whiteboard from last time. So we talked about how when we're communicating with HTTP to a service or an API, this takes time. That means that now when we design our React application, we have to factor that in. So when we make this request to the Open Trivia database, it's going to take time to get there, so we need to display some loading information, and that could potentially error out. Like if the database went down, this API went down, then our application would go down, and we would need to gracefully catch that and display a message to the user to say, hey, something went wrong, try again later. So our application, which currently loads immediately into the quiz game, is now going to look something like this. This will be our initial loading state, where we will have our nav bar and all that stuff at the top. And then when we're on the quiz page, we'll display some kind of loading spinner here that'll be spinning around until either we get successful data or it fails. So we can mark this as success for our fetch and fail for our fetch. If there's a success, then we can move from the page that we have with the loading spinner to actually display the score and the question and the buttons below it, just like normal. And if we have a failure, then we need to handle that gracefully and display something to the user where we say, you know, something went wrong. Please try again. I'm just going to put some squiggles here for the rest of the error message text. And just a clarifying note about this error message. When we display an error message to the user, this is going to be distinct from the error message that we would put in our console. Because, you know, a network error might trigger something that says like type error, cores was not configured properly. That means nothing to a user, but that's important for us for development. So we'll have to kind of differentiate between what we display to the user and what we log to the console for us for debugging purposes. So with this new structure, we are going to need to store some additional state. So we're going to need to know when we're in this initial loading state. So we'll have a Boolean that says whether we're loading or not. Then we're going to need some state that stores our error message, and then some state that stores our actual trivia data. Okay, so let's get started. I have starter files set up here that we can use for this project. It's basically the quiz version that we created in the last quiz video, but it has two extra components that are just to help us go quickly through getting this set up. So there's an error message component that just displays a styled error message to the page. And there's a loading spinner component that displays a little spinner that we can use that has a little animation that we can use to display when something is loading. So I'm not going to dig into this too much. I have done the JS docs for this. So if you decide you want to configure anything about these components, you can look at the JS docs and you can dig into the associated CSS. So you can grab these from the starter files, or you can just grab all of the starter file project and work from that. Make sure that if you are grabbing the starter file that you run npm I or npm install, and then when we're getting started here, remember to run npm run start or npm start to get our server up and running. We're back in the world of React, so we're not using live server, we're back to using the npm scripts to run this. So I already have mine running in another terminal here, so I'm just gonna hide this and head over to our quiz page. So this is the page where we're gonna wanna do our fetching. So before we even put the game onto the page, we wanna talk to the server, get the trivia items, and then pass that into our game component. So this quiz page is going to either display the loading message, the error message, or the game. So it's in charge of fetching that information and putting the right component on the page based on our state. Just to get started here, let's bring in those loading and error message components and use them here. So I'm going to comment out the game so that we don't have our game loading on the page. And if we bring in the loading spinner and make sure to import the loading spinner from common loading spinner. This is just a simple spinner with a CSS animation that rotates this rounded box on the page. If we wanted to dig into it, we could go to the loading spinner and look at some of these properties, like there is a size property that we can configure. There's a border width, color, screen reader message. I'm going to leave it as the default, but maybe in future videos we'll come in and configure it for different situations where we want a loading spinner. Let's also put an error message on the page here. And be sure to import the error message component from common error message. So this component takes in whatever children you give it and wraps it in this paragraph that applies styling to make the text look like an error message. So instead of doing a self-closing tag, let's do one that has children, and we can say something went wrong. And if we check it out, here's our loading spinner, here's something went wrong, and we're not going to show these both at the same time. We're going to either or show one of these. But this is what we've got to work with. So what we want to do is inside of our quiz page here, create some new state. I'm going to call this state quiz fetch. And use state and make sure that I import from React, use state here. I'm just going to bubble this up to the top since I like to put my dependency imports before my internal project imports. So we need state that keeps track of a couple of things. Is loading. So this is going to be our Boolean. If we have started a fetch and we're waiting for the fetch to resolve, this will be true. As soon as we're done, it'll flip to false. We want to store an error message string in here. So I'm going to start this as an empty string. And then we want to store some data in here, which I'm going to store as null to specifically mean that we have no data in our initial state. And you can store all three of these in separate variables. You could create another piece of state here for is loading and set is loading. and do the same thing for error message and data. But since these are three things that are grouped together and we're going to be changing them simultaneously, like when our isLoading changes from true to false, we're going to be updating one of these at the same time. It makes sense for us to just bundle these pieces of state together into an object. So let's get our conditional logic working. We've seen before that we can do something like if we're loading, do one thing. Otherwise, we could put something else on the screen using a ternary conditional operator here. But I find that as soon as I have more than two states that I want to flip between, this becomes hard to read. So I usually break this out. And so I would say, whoops, just Control Z to get the loading spinner here. What I would do instead is create a variable called contents. If we are loading, then the contents are equal to our loading spinner. So we can put JSX into this variable. Otherwise, if the quiz fetch has an error message, our contents should be equal to an error message here. And we will put in whatever this quiz fetch error message is. Actually, let's, to shorten this up, I'm going to destructure our state into 3 local variables. So I'm just grabbing each property, putting it into its own variable so that I don't have to say quiz fetch is loading, quiz fetch error message. I can just say is loading an error message. And then here we can put our error message. And if it's not loading and we don't have an error message, then our contents can be our game component. And then down here, instead of putting all of those on the page, we can put our contents variable. So this structure ensures that we've got a main element on the page and that the content inside of there dynamically switches based on our quiz fetch. I guess looking at this, I might change error message. This is relying on the fact that an empty string is falsy or is converted to false inside of JS. Maybe I would want to make this a little bit more explicit and say that as long as error message doesn't equal an empty string, then we'll throw an error message on the page. So just with this, we can go back to our developer tools. So if I inspect our page and I go to our React components and go to our quiz page here, I can see the state objects with our 3 properties. And if I change these, it should change what is rendering if I've written that conditional correctly. So if I take the isLoading state from true to false, and we have no error, then our quiz shows up on the page. So that looks like it's working. If I go back to loading, and let me set an error message. And I leave isLoading, there's our error message showing up on the page. So even before we mocked out our fetch logic, we've got our state hooked up correctly to do the conditional rendering. So now the next piece of the puzzle is how do we do the fetch logic that we were doing in regular JavaScript inside of our React application? Because there's an added wrinkle. Let's go back to our component and let's say that we just ran a fetch here. I'm going to simulate it using console log. So anytime we see console log in our console window in the browser, we know that a fetch would have been initiated. So if I load the page here for the first time, okay, that seems right. It says fetching once. But if I flip back to my components here, and I'm going to hit escape to pull up my console while I'm on this page here, and I go to my quiz page, I change the state, our component re-renders, so that function is called. So we would have just, when the state changed, started a new fetch. And if the state changed again, a new fetch would be initiated. And if the fetch changes the state, we would end up in this kind of infinite loop of our fetch, changing the state, causing a new fetch, changing the state, causing a new fetch. So this would be really bad. So we need to be careful about where we put this fetch logic. We could, if we put a button on the page and we did our fetch when the button was clicked, that would work because we could control when that fetch is happening to only initiate it on a button click. That would be fine, but that would make for a tedious interface if when our application starts, the user has to press play here before a quiz loads. So another way to do this is using one of the hooks that's built into React, the effect hook. The effect hook allows you to run side effects inside of your functional components. So these effects that you create run after the render logic has finished. In this case, this sample is putting a button on the page with a click counter so that the page always displays how many clicks, how many times you've clicked on the button. The effect here, so UseEffect is being passed in an arrow function. This arrow function runs after the component re-renders. This is just changing the title at the top of the tab to be that you've clicked X number of times. So every time the state changes and this component re-renders, after the render has finished, this logic goes ahead and changes the title in the bar. I recommend checking out the rest of this page. There's a lot of good information like how to clean up your effects on this page. We're going to be diving into this, and I'm going to show you basically the core concepts that we need to do a fetch, but you can see there's a whole lot here that's useful to know about. So if we flip back to our code, instead of doing this on click, what I want to do is make sure that I import UseEffect here. And then I want to use effect, and UseEffect takes in one required parameter and one optional parameter. The required parameter here is the function, is the effect that you want to run. So we put our code into this function. So let's put our console log fetching in there. This is going to run after the component renders. So far we haven't fixed our problem, but we have put the fetching inside of an effect. So if I just flip back here and go back to our page, refresh this, it's still going to be that if I go to my quiz page and change the state, our fetching is still going to happen. But the second parameter that you pass in is the dependencies. So you're saying with the dependencies, only run this effect when something in this array has changed. So if you want, you can specify something like your state variable, like if we wanted to run a new fetch every time quiz fetch changed, we could do that. Or if we had some other variable, like an ID that we wanted to use to initiate a fetch to go ask for a specific quiz, we would put that here. If you specify nothing, this effect runs when the component is mounted. So that's an important point here. Empty array for dependencies means the effect only runs on mount. So now if I refresh the page, our quiz page is mounted, is loaded on the page here, and we can see fetching is printing out. If I change the state, doesn't matter how many times I change the state, this fetching doesn't rerun. If I do go to another page and come back to our quiz, our fetch is reinitiated because our quiz page has just loaded, has just been mounted again. So we should now know how to do our fetching logic. It is basically just taking what we did in the previous basic JavaScript version and putting it in here, inside of our effect. So I'm going to copy over some pieces, like this URL. And we want all of this so that we can run our promise logic through await, so that we can write our code in this synchronous looking fashion. We need to wrap all of this in an async function. So I'm going to do a similar thing here. Inside of this effect, I am going to create an async function and call it getQuiz. I'm going to move my URL in here. And at the bottom, we are going to run getQuiz. Let's put our fetching in here. So nothing should have changed. We're just setting up our async function so that we can use await in here for our fetch. And the reason why we have to do this is because we can't mark this function as async and have React know what to do with this function. Kind of get into later how the cleanup works and why this wouldn't work for marking it as async. So we have to create a function that's nested inside of our effect arrow function that is async. Okay, so we're going to do our fetching. We will get our response here, and that is going to be by awaiting our fetch operation to this URL. And then we want to get our JSON by awaiting the response.json promise. And then when that's done, we should be able to see the JSON in here. So we should see fetching printing out, and then some number of milliseconds later, we should see the JSON printing out. So fetching, and then we get our quiz or trivia items here. So we get our response code and our results. So this is great as long as something doesn't go wrong. And last time we learned that we had to handle errors, like if this fetch broke, instead of staying in the loading state, we actually have to display an error message to make sure that the user knows something went wrong and that maybe they have to try again later. So let's bring over some of that more complex error handling logic that we were doing. So the first thing we did was after we got the response, we checked whether the response was okay. And then after we got a successful response, we checked the response code to see if the API was telling us, oh, there was something wrong with your request. And all of this we did inside of a try catch block so that if an error occurred, we would end up down here and we could console log that error or do something else with the error. So if we flip back, we're going to do a similar structure here. All of this logic is going to go inside of a try block so that we can throw errors and have them be caught down here in a catch block. And that first thing we were doing was if the response is not okay, then we want to throw a new error, which will stop the rest of this processing from running and end up down here in our catch block. And I'm just going to copy and paste this from our previous version. We said that something went wrong. Zoom out slightly so we can get this all on the page. Something went wrong. Server responded with this status code. So then we can go down to add the rest of that error logic. So after we got the JSON, we wanted to pull out the response code and the results array from the JSON. and check that that response code was not 1 or 2, which we learned last time. 1 is a bad API request that has no results, and 2 is one that has invalid parameters. So I'm just going to copy and paste this over here. So if we passed this check and these checks, we know that our results array is good to go, and we can store that in our state variable here into data. So this is successfully passed all the error checks. So we can set our quiz fetch state to be is loading, false, error message, empty string. So this would, if there were an error message, this would clear it and set it back to an empty string, and we definitely want is loading to be false. And then our data property can now be set to our results array. So this thing that we grabbed from the JSON is now stored into our state variable. So as long as we make sure that this URL is correct, we should be able to see all of this and use our dev tools to see that data being loaded properly. So we can see fetching printed out here, and then if we go to our quiz game and look at our state, we can see here's our data. Eventually we'll need to hook this up to our quiz game so that it loads the right questions, but we can see our data. We've got the right flow for the success, so now we need to do the flow for if an error occurs. Whoops, wrong one. Here we go. So now what we need to do is write our catch code. So I'm going to grab this. And what we want to do here is display a generic error message. So we don't want to display this, like that there was a server, that the server responded with a bad code. We don't want to tell the user that there was a bad API request that got no results. We just want to let them know that, like, oh, something generic went wrong. Maybe try again later. So something went wrong loading the quiz. Please try again later. And instead of setting the data to null to results, which we don't have here, we're going to set it to null. So we're no longer loading, but we are storing a error message in there. So this is what the user sees. What we see as developers is a more specific error. So we'll display specific error for debugging in the console. And we will just take whatever error we're being given here and console log it. So we'll know if it was a problem with the response from the server or if it was a problem with our API request. We'll be able to see that in the console. So let's check out that flow. We should be able to mess up this URL and see that something went wrong loading the quiz, and that is coming from our error message state variable here. And we should be able to see this specific error message that we're getting, one of these three, in our console. So with that previous error that I was making, that was a type error that was occurring actually from this line, from our fetch. This fetch failed, but if we do something like amount equals 5 with AMT instead of amount, this should now be a bad API request. So we should see this print out to our console. Bad API request, invalid parameter. So this is for the user. We want to display something generic that gives them the best idea of what they can do. And this is for us so that we could then come in to the broken version and be like, oh, we messed up something in our code where we were reading in the URL or constructing the URL. We need to fix that before deploying again. Okay, let's fix that. Get it back to a working version. Good. I do want to add one to-do note here is that in the future, we want to make sure that we unsubscribe or clean up here. So we should, in the future, we should clean up if the user leaves the page before fetch finishes running. I don't know if I'll be able to simulate this here in the browser, but if we go to the quiz and quickly switch to another page, nope. There we go. So what I did was I went to the quiz, started the fetch, switched to the about page, so our quiz is gone, but the fetch resolved and tried to update the state in that old component. So this is an edge case in our current application. And to make sure that we're not making things too complicated for starting out here, we're not going to worry about that, but we will learn how to deal with that issue in the future. Okay, so we have our loading message, our error message, and our data all working from the perspective of the quiz page. But our game down here doesn't know about that. We haven't passed the data down to the game, so it is always loading this question about the oldest board game, even though if we look at our state here on the quiz page, the first question here is a history question about the United States National, the NSA. So what we want to do is our quiz game, instead of importing trivia data here, we'll just set that up to be a property. So if game expects for a trivia data prop to be passed in, if we give it an array of questions, this code should suddenly start working because all of our variables down here expected a trivia data array. So right now, if I save it, this should break because we haven't passed in that trivia data. So as soon as it tries to do something with that array, it's not going to work. But if we make sure that when we put the game on the page, we pass in trivia data prop and we give it our data. So this is coming from our, let me collapse this so we can see it more effectively. Whoops, that's not what I meant to do. That's what I meant to do. So here we destructured our quiz fetch, and why don't I move this down here so this is a little bit easier to see. Our data gets passed into the game component and then put on the page. And with that small change, we should now have a new question that is dynamically fetched from the trivia database every time we refresh this page. Now, the one problem with what we're doing is when we fetch our results, we're throwing that array directly into our state. But what we were doing previously, which here's our array, was processing that array and using the HE library to decode the HTML entities. So if I flip back here and refresh it, we can, here we go. Here is an HTML entity that has not been properly rendered to the page. So we just want to make sure that we run this logic. So I'm going to copy it from our trivia data here. I'm going to call this decoded results, and it's going to be our results array where we map over it and run the decode on the question, correct answer, and our incorrect answers, and make sure that we put the decoded results in our state, and then we will import the HE library up here. So import HE from HE. So this should properly decode those HTML entities right after we get them before we store them in our state. So our quiz game should get the decoded results. And anytime we see quotation marks in here, those were things that were HTML entities before. So since I can see them, I know that it is now working. We have decoded those results. So at this point, we learned how to go from our HTML version of fetching to our React version of fetching. And the key or the keys were that we needed to maintain a couple pieces of state to know when we were fetching, if there was an error, and what the successful data was. And we had to make sure that we did that logic in the appropriate side effect, that we didn't try and run this at the top level of our functional component here, because if we fetch here, that runs every time the quiz page is rendered. But since our effect, we passed in an empty array, we were able to say this side effect only needs to be run and only should be run when our quiz page is loaded for the first time. So that is it for fetching from React. In the future, we will learn how to clean this up. Right now our quiz page is doing a whole lot of logic. So it both is storing the state here, doing our conditional rendering, and doing all the fetch logic. And using something called custom hooks, in the future, we'll be able to separate all of this out. But we have successfully gotten some HTML, some HTTP communication with a backend happening from our front end.